All right, here we go, day 66. The lesson is 7.1, day 2, and the 3-minute review is a question straight from the homework yesterday, or pretty close anyway. Ferd figures he spends about 130 bucks a month on cigarettes. If he invested the money instead, how much would he have in 5 years? So this is one for all you smokers out there. Um, we're going to say if he, and we could do this on a table, but I'm going to use a formula. Why not? We sort of decided we like that way kind of better anyway. What do we got? The amount at the end is what we want to find. The regular investment is 130 bucks a month on cigarettes, and interest is 9% compounded monthly. So I got to do that. And does that go evenly? I hope so. We're going to have to worry if this ends up a decimal what to do, but for now it's worked out nice. 5 years, 12 times a year is 60 payments. I'm glad we didn't decide to do a table because it would have 60 rows in it. That would have stunk a little bit. And then off we go. 1.0075 to the exponent 60 minus 1 all over I, which is 0.0075. And I put that into a calculator and I get, rounded to 2 decimal places, 9805.14. And hopefully you're okay putting that into your calculator. Shall I go through it? I'll go through it. What the heck? One more just in case you missed it yesterday, eh? 130 times bracket. I'm going to put 2 brackets in there, right? Bracket, bracket. 1.0075 end bracket. Although those brackets, we don't need them, but we're putting them in there just because we're following along with what the formula is here. Minus 1 end bracket divided by, and then 0.0075, and I should get the same thing. Yeah, right there. So Ferd, wow, Ferd could have, just from quitting smoking and putting the money in a bank, almost 10,000 bucks in 5 years. 10,000 bucks. Wow. Okay, what are we up to today? What we're doing today, essentially the same types of questions that we did yesterday, this idea of a regular payment, but we're going to use a different tool. We're going to use the graphing calculators. Yep, we use the graphing calculators for this as well. Use technology to solve investment and borrowing problems. This part of the graphing calculator is called the TVM solver, time value money TVM solver. It's essentially a program that's built into the graphing calculator that helps us solve these questions. And maybe you used it last year in grade 11, maybe you didn't, doesn't matter. So it says to get to this TVM solver, hit apps, turn the calculator on, I guess, first, hit apps, and then finance. And then there's a bunch of selections, and we're going to hit TVM solver. Now remember, of course, these will be available for you in class, and on the final exam. There's going to be one of these things sitting on your desk for the final exam. But remember, you can download this program, the program that you're seeing on your screen. This is just a software program. You can download this and put it on your computer. Remember, there's also some of these in the library that you can sign out if you want to practice. So it's nice to have this to follow along with when you're going through these videos. And there's the TVM solver. Now, this one's got some stuff already in it, and yours might be blank or whatever, but I'm going to go through and just say what these things are. N is exactly what you think. It's the number of payments. Or periods. We've always thought of those things as the same. Number of periods or payments. I is the interest rate. And this is, I don't have to divide it by anything. It's just the interest rate as a percent. So we used to have the 6% per year compounded month. We just put in the 6, so this would be just 6 here, and we'll see that when we get to an example. PV, what was that? Present value. We think of this as P in our formulas. PMT is payment, figures, kind of makes sense. And this we think of as R, the regular payment. FV stands for future value. And we think of this as A in our formulas. These two things, the PY, CY PY stands for payments per year. And the CY is compounding periods per year. And maybe you noticed that in the questions that we had, Ferd, when he was investing, he's investing the money per month, and then the compounding periods were per month. They always matched. These always match, at least until later in the chapter when they don't match. So that's something for us to think about. And now basically what we do is we fill in these values and we can solve for the other one. So let's get to the example. Solve the 3-minute review question using the TVM. Write values you typed, then a closing statement. So, well, what did we have? N was the number of payments, which was the 5 years times the 12 per year. That was 60 payments. The interest rate that Ferd could get was 9. There was no present value. That didn't make any sense in there. The payment was $130, wasn't it? $130 a month. The future value, that's what we want to find, right? That was kind of A. That's what we wanted to find. That was the question mark. The periods per year and compounding periods per year, payments per year was 12. It was monthly, and the compounding periods were 12. And you'll notice that when you put that in there, that it actually changes. So I'm going to put in there 60. The interest rate was 9%. The present value was 0. The Ferd had no money in his account at the start, but we could change that if we wanted to. And the payments were 130. Future value we want to find, so I'm going to leave that for now and show you how this works. The payments per year were monthly, and the compounding interest. And notice when I went down to get to CY, it changed from 12 to 12 there. Now, how do we actually solve? Is we go up here, and this is the one that we want to solve. So we put our cursor on the thing that we want to put, that we want to solve for. Cursor here. And then this is what we do. We press alpha, the green button, and then enter, because you see the little solve? That's the one we want to solve for. Alpha, enter, and then bam, it just does it for us. And notice that it puts a little box next to the one that we solved and solves it. What was it? 9805.14. So I'm going to write those steps here. Cursor here, then what do? We pressed alpha. Clean that up, that's terrible. Alpha. And then enter, which actually was the solve command. And then it just solved for the future value, and it was all good. So we say Ferd would have 9805.14. This is pretty slick. Pretty slick. So let's solve some more problems using this. It says the TVM solver can be used to solve normal compound interest questions too. So this is the idea of when it's not a regular payment. Ferd needs to have $1,800 to pay off again. Oh, Ferd has gotten into some trouble by gambling. He He needs to have $1,800 to pay off a gambling debt in 2 years. Right now, how much would he need to put into account paying 7% compounded monthly? Okay, well, let's go through this and figure out what's what. N is the number of periods, right? It's 2 years, but monthly is 12 times a year, so 2 times 12, that's 24 we're going to put in there. The interest rate was 7%. The present value that's what we want to find, right? How much would he need to put in an account now? Now, that implies present value. And notice that there's no regular payment here, right? There's no regular payment, so we're going to leave that at 0. Future value, that's $1,800 that we want to have so he can pay off his debt. The payments per year and compounding periods per year, it's monthly again, so those are 12. So let's do this. And we're going to switch these values here. That's going to be 2 times 24 and 2 times 24, 2 times 12 rather, which is equal to 24. 7%. The present value we're going to solve for. The payment was 0. It wasn't regular payments. And the future value has got to be $1,800. The periods per year and compounding periods per year is 12 and 12. And so we're going to solve for how much he needs to have now. Alpha, solve, and there's the 1565. Notice we would have got that using the other formula. $1,565.48. One thing I want to mention here, you probably noticed this. This ends up being a negative. And this is just something that's got to do with the way the calculator works. It's kind of like if Ferd's going to have $1,800 coming out of the bank at the end to pay off this debt, how much goes in? So it's opposite, right? So one of the payments is out of Ferd's pocket and then into Ferd's pocket. And so the idea is one has to be positive and one has to be negative for it to end up evening out. And don't worry about that. If this one wasn't going to be negative, then this one would be. Okay, because they even out. And notice that would be this formula, right? No regular payment. There's no R in this formula. So the present value would have been what we were solving for. A would have been 1,800 and N would have been 24, and the interest rate would have been 7% a year compounded. That's not very nice. That's a decimal, and that would have been a mess. So it's a good thing we were using our calculator here. Feels like I'm time for a pause in this video at 13 minutes, and we'll pick it up example 3 in part 2.